Today we will be in Chapter 3, Section 2, Solving Application Problems. Our three topic objectives for today are to solve number application problems, solve application problems involving money, and to solve applications concerning percents. Chapter 3, Section 2, Solving Application Problems. Before we dive into solving more word problems, I do want to remind you that in 3.1 there was a really nice handout that has been posted on your Course Compass site, and that handout really explains a lot of the material that you'll need as backup or background material for this section. So if you haven't already done 3.1, you need to go do that homework first and get that handout out so you can successfully do 3.2. Okay, so in order to do the problems in 3.2, we need to know what our problem-solving procedure is. Step 1, you will understand the problem. That sounds easier said than done sometimes. Step 2, you will translate the problem into mathematical language. Step 3, you will carry out the mathematical calculations. And then step 4, you will check your answer, because that should always be your final step. For this set of notes, I'm going to get the online textbook open so that we can have the word problems right there in front of us, and I will show you how to access that. Hopefully by now you've found where the online textbook is, but I will show you how to find that as well. Okay, so you need to get logged into your Course Compass site and select our class. And then what you need to do is you need to go over to the left-hand side and click this Multimedia Library. This is where your online textbook is. Hopefully you've already found that this semester. But just a refresher, we're doing Chapter 3 and we're doing Section 2, and then I'm going to select all and find now. And when you do that, it's going to pull up a whole bunch of stuff. And if you haven't, if you found the textbook before, then that's great. But there's also videos that come along with the textbook and test prep videos, and there's also a PowerPoint which has notes laid out, very much like the notes I'm giving you right now. So if you like PowerPoints, I really recommend using all this information that the book comes with. But we need to open up our textbook. So get that opened up. And here is our online textbook. And if you look, this looks exactly like a page out of the actual textbook, which is why we don't make you buy the actual textbook, because you get the online version. So I'm pulling this up so that we can work some of the examples, because it's easier than me having to write them out every time, and it's easier for you to read them straight off of here. So if you want to follow along and have yours open as well, I'll be on page 180, and I'll be doing example number 1, which I'm going to try not to give you all of the answers right off the bat. So let me pull up my note page. There we go. Okay, so example number 1 is right here. And it says 2 subtracted from 4 times a number is 10. Find the number. Okay, so like I said, in 3.1 we learned kind of how to approach these problems and how to really understand how to write this in mathematical language, I guess. So the one thing you need to remember is the word is always going to be the equal sign. So right there we know our problem is going to be equals, and then it says 10. Okay, so there's half of our equation, kind of. So we're done with that part of it. Now we have 2 subtracted from, and then all this other stuff. So that means 2 subtracted from, that's going to come last, because you have a number and then you're subtracting 2 from it. So I'm going to do 2 and then minus, and that's going to get rid of this first stuff. Now I just need to know what we're subtracting that 2 from. It says 4 times a number. Okay, we don't know what the number is, but we know 4 times that, we're going to subtract 2, and we're going to get 10. So I like to let my number, a number, be x. And we have 4 times that, so we'll have 4x. So you should have 4x minus 2 equals 10. That's what that whole first line is. And then it says find the number. So we have to solve this equation. So I'm going to add 2 to both sides. And then I'm going to divide by 4. So I get x equals 3. And just for sake of time on these notes, I'm not going to check my answer. But the nice thing is since we're doing examples from the book, if you click on your book, you can see what the answer is supposed to be, and it also works it out for you. And it kind of will help you because it says 2 subtracted from 4 times a number, and then it shows you where it gets that from. And then it says the is the equal sign, just like I told you, and then 10. So your book is actually very, very beneficial, especially when it comes to these word problems. So please don't neglect looking at your book. Okay, so that was example number 1. Now I'm going to turn the page and go to example number 2. Again, I'm going to try not to give you the answer straight off. This is another word or a number problem. There's 3 types of word problems you're going to have in this section, and there's number problems, and there is money problems, and then there's percent problems. So these first 2 are number problems. And I'm getting these out of your book, but these are exactly like the ones that are on your homework and exactly like the ones that are on your quizzes. And everybody likes to skip over the word problems, but I need to stress the importance of this because this will show up on your final exam. It always does. There's always word problems on your final exam, so please don't neglect learning how to do these problems. Okay, let's do example number 2. It says the sum of 2 numbers is 26. So we have 2 numbers, and sum means we're going to add them. Okay? So it says find the 2 numbers if the larger number is 2 less than 3 times the smaller number. Okay, that is a whole lot of information. So let's focus on the first one, the first line. It says the sum of 2 numbers is 26. So we know from the question we have a larger number and a smaller number. Okay, so I'm just going to say my larger number, I'm going to label that with an L, and my smaller number, I'm going to label that with an S. If you like A's and B's or X and Y, you can do however you like. I like to do that so then I can keep them a little bit straighter when I'm reading through the words. Okay, so the sum of 2 numbers is 26. So if I have my L and my S, it's going to be 26. I add them together. That's what sum means. So right there, we're finished with that first line. Okay, it says find the 2 numbers if the larger number, so that's our L, so if our larger number is, right there we see is, that's an equal sign, 2 less than, so again that's going to be a minus 2 because it's 2 less than something, and our something is 3 times the smaller number. So we have 3s. And if you read this second equation, it says L is, so larger number is 3 times the smaller, subtract 2. And that's exactly what that second line says. So now we have 2 equations with 2 unknowns. But if you look, we said L equals all of this stuff. So that means we can take all of this stuff right here and we can plug it into our first equation wherever there's an L. So right there. I'm going to rewrite it so that it looks nicer and I can show you what I mean. So instead of L plus S, I need to say 3s minus 2 plus s equals 26. Because all this stuff right here is what L equals. So I'm going to do that, and then I need to solve for my variable, which is my s in this case. So 3s plus an s will be 4s. Still minus 2 equals 26. I need to add 2 to both sides. That'll give me 28. Divide by 4. And I get S equals 7. So we know our smaller number is 7, but we need to know what our larger number is. So at the very beginning we said the larger number is 3 times the smaller number minus 2. Now that we know what S is, we can just plug that in. So we get L equals 3 times 7 minus 2. So L equals 21 minus 2. And that means that L equals 19. So we got S equals 7 and L equals 19. This one's a little bit harder. Obviously we have 2 equations and we have 2 things that we don't know. So let's check if our answer is correct. We have 7 and 19, and according to the book we have 7 and 19. So we did that one right. Again, I'm getting these straight off of your textbook, which means there's a lot more examples in the textbook that you can use if you'd like. And then you can also use your homework and hit the similar exercise button, and it'll keep giving you problems to use, which is very, very nice. Okay. I am going to move on and do a money problem. So you need to go ahead to page 182. Excuse me, 183. And we're going to do a money problem. And I did write this one out before. I was like, I'm just going to get the pages opened up on your book. But we can read it straight off of your book. And it says, Grub Problem. Part of Kim Martello's lawn was destroyed by grubs. She decided to purchase new sod to lay down. The cost of the sod is 45 cents per square foot plus a delivery charge of $59. If the total cost of delivery plus sod is $284, how many square feet of sod was delivered? This is actually a very nice problem because some of you might end up having to buy sod, or you might have to buy tile for your house, or you might have to buy flooring, or any number of things like that. So this actually does come in handy when you're trying to figure out whether or not it's cheaper for you to buy it and do it yourself, or if it's cheaper to have it delivered and things like that. So there really are real-world applications to these problems, just in case you think math is pointless. Okay, so she has to buy new sod. And we need to figure out, the very last question says, how many square feet of sod was delivered? So we don't know how many square feet. So the square feet of sod is going to be our variable. So that's going to be our x. We don't know how many square feet of sod we have. So we need, there, that's better. We need that to be our variable. But we know, according to the question, if the total cost of delivery plus the sod is $284. So we have delivery plus the sod equals $284. That's what it says. Then we need to find out how much sod we have. Okay, we know our delivery charge is $59. It says that in the problem, $284. And then how much is our sod? Our sod is 49 cents per square foot. So that would be 59 plus, we'd have 49 cents, so that's 0.49, or 45, excuse me, 45 cents per square foot, and we don't know the square footage. We said that's going to be our x. So we have 59 plus 0.45x equals the $284. I'm going to slide that up. So that right there is our equation for this problem. Now what we need to do is we need to solve for our x. So our first step should be to subtract the $59 from both sides. So we get 0.45x equals 225. And then we have to divide both sides by 0.45. And if you do that on your calculator, you'll get x equals 500. And what was our x again? Our x is our square feet of sod. So she had to purchase 500 square feet of sod. Again, this is the word problems everybody seems to hate, and the reason why everybody seems to hate them is because it's not just a do this and then you're going to get the answer. You have to really have to learn how to read the math and then how to translate it from words over into mathematical language, and that does take some practice and it does take some repetition. So, I mean, just working through these problems over and over and over again really will be the best thing for you. Let's check and see if that's the answer they got. That is the answer that they got. So I'm going to move on and do example number 6. Again, I'm on page 183. Do example number 6. And I didn't write this one out, so I won't have it for words on my own paper. Okay, example 6 is a photo printer problem. Again, this is another money problem. It says Elsie Newman is going to purchase a photo printer to print pictures from her digital camera. She's considering a Hewlett-Packard printer and a Lexmark printer. The Hewlett-Packard printer costs $419 and the cost for ink and paper is 14 cents per photo. The Lexmark printer costs $299 and the cost for ink and paper is 18 cents per photo. How many photos would need to be printed for the total cost of the printer, ink, and paper to be the same? Okay, so I'm going to write out a whole bunch of stuff and then it'll make more sense. Okay, so the first thing is I want to go back up to about halfway through our problem where it says the HP printer costs. And I'm going to write an equation for how much the HP printer costs. So we have the Hewlett and Packard printer, the HP one, and it cost $419 plus 14 cents per photo. So plus 0.14 cents per photo. And my photos are just going to be my x. So x equals the number of photos. So right there I have an equation for the cost of my Hewlett-Packard printer. Okay, so now I need to do the same thing for my Lexmark printer. And I'll just do that with a capital L. So my capital L printer cost $299 plus it's going to cost 18 cents per photo. And that's all we know number-wise. But then our question says, how many photos would need to be printed for the total cost of the printer's ink and paper, blah, 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 to be the same? Okay, whenever you see something say the same, you need to think that that means you're setting them equal to each other. So same, setting two things equal, because we want to see where they're equal. So that means we need to set our Hewlett-Packard and our Lexmark printer equal to each other. And then we need to solve for our x. So if our Hewlett-Packard printer is 419 plus 0.14x, and our Lexmark printer is 299 plus 0.18x. So now we just need to solve for x, because that will tell us how many pictures we can print on both of our printers for the cost to be the same. Okay, so I'm going to subtract my $2.99 over, because I want to keep everything positive if I can. And because I think you all at this point should have a grasp of how to solve these equations, I'm going to go ahead and do the minus 14x as well. Just save us a couple of lines of paper. Okay? So you get 120 equals 0.04x. Then you have to take both sides and divide it by the 0.04. And you get 3,000 equals x. So that means Elsie could print 3,000 pictures on either printer, and it's going to cost her the same amount of money. Let's see if that's what they got. And they did. They got 3,000. There is always a problem like this on your final exam. Always, always, always. So make sure you understand how to do these. Again, this is one of those times where I wish I had you guys in class so that I could see if there's blank stares at me or if you're understanding it. Okay, we've got two more problems. Those are the two types of money problems. You did the two types of number problems. So now we're going to do the two types of percent problems. Pull this down. Okay, so we have 2% problems. I'm going to go ahead and go to page 184. And we're going to do example 7. Okay, so it says a water bike rental at a beachfront hotel. The cost of a water bike is $30 per half hour, which includes the 7.5% sales tax. So we want to find the cost of the rental before the tax. So this already includes the tax, which I don't know where you go that actually includes the tax, but this place does. This place includes your tax. So we need to know what is the cost of the rental before the tax. So that is going to be our x. So x equals cost of rental before the tax, because that's our unknown. We don't know what that is yet. But we do know that we have tax in ours. So that means we have 0.075. That's our 7.5%. Because remember, when you change percent, you have to move your decimal back. So 0.075x would be the cost of the rental with the tax. Because when you take taxes, you're taking 7.5% times every dollar. So you have to take that times the cost of the rental before the tax. So this is cost with tax. So we know that the cost of the water bike is $30 per half hour. So the cost of the water bike is going to be the cost before tax plus the cost with tax. Because when you take this 0.075x times however much the cost of the rental is, That's just telling you how much you're paying in taxes. So if you think about this as, because it's going to be x plus 0.075x, and that's going to equal your $30. This one's a confusing problem for a lot of people because it looks like we're adding the cost of the rental before tax twice, but we're not. The thing you have to think about is when you go to the grocery store and you have your receipt, you have your subtotal, and then you have to take taxes times however much your subtotal is and add that on to get your total cost. So this is our subtotal, and then this is just how much in taxes we're paying, and then that's the $30 per half hour. So we need to solve for our x. So we have 1x and then 0.075x. So it'll be 1.075x equals 30. We're just going to divide both sides by the 1.075. And we will get x equals, and it's going to be kind of a weird number, I'm sure. Yeah, you're going to get 27.9069767, and if your calculator goes on further, then you'll get more numbers. But what did x stand for? X stood for the cost of our rental before taxes. So we're doing this with money, so we need to round this. So you have x, and then when you're doing an approximation, you do a squiggly equals. It's not super important, but just letting you know. And you get 27.9, and then we need to round, and since that's a 6, we're going to round up. So before taxes, our water bike costs us $27.91 per half hour. This one is just what you're going to use every day when you go to the grocery store or go to Walmart. So you spent $27.91 on all your stuff, but then you have to add in however much taxes is going to be, and when you do, it gets you to that $30. That's how this problem works. So this is an everyday type of problem. Okay, let's do another example. We're going to skip number 8 actually, because you don't really do a problem like that on your tests, and I don't want to overwhelm you. But you do a salary problem on your tests and on your quizzes, so I wanted to make sure we covered a salary problem, which again is just another form of a money problem. Okay. This will be our last example, and then I'm going to just let you go so you can do your homework, because these are exactly like the ones on your homework. And all you need to do is do those and then hit similar exercise to get more practice. Okay, so example 9 says salary plans. And Jeannie has accepted a position selling medical supplies and equipment. During her first year, she's given a choice of salary plans. Wouldn't that be nice? We are given plan 1, which is $450 weekly, plus 3% commission on weekly sales. Okay, so I'm not even going to read anymore. I'm just going to make an equation for plan 1. So we have plan 1, and I'm going to say equals because this is what we're trying to figure out, is what is the best plan. So plan 1 is $450. She's going to get that regardless. And then she also gets a 3% commission on weekly sales. So plus 0.03, and then commission is however much stuff you're selling. So we don't know what that is. So I'm going to say X is my commission. We don't know how much that is, but we're going to get 3% of it with our plan 1. Okay, plan 2. Plan 2 is a straight 10% commission of weekly sales. Okay, so for plan 2, she doesn't get a base salary. She doesn't get that $450. All she gets is 10% of whatever she sells. So that means she gets 0.110 X. That's it. There's nothing else. So if she doesn't sell anything one week, she doesn't get paid that week. So what weekly amount of sales would result in Jeannie receiving the same salary from both plans? Again, notice that word same. That is very important because just like from a problem a few ago, we said same means we're going to set them equal to each other. So that means we need to set plan 1 equal to plan 2 in order to determine how much she needs to sell to make the same amount from either plan. Okay, so that means we have $450 plus the 0.03x equals the 0.10x. I'm going to subtract over my 0.03x, and I get 0.07x. Then I will have to divide both sides by the 0.07. So, 0.50. And I get 6,428.57. Again, I'm doing squiggly equal signs because it did have more than that, but we're dealing with dollars. So she'd have to sell almost $6,500 worth of stuff in order for these two plans to be equal to each other. It sounds like quite a bit, but I guess when you're doing medical supplies, it might not. Okay. So, like I said, that was the last problem I was working with you. I hope this wasn't nearly as confusing as it could have been. Again, if you have not looked over 3.1, you really need to do 3.1 before you do this. It will really help you get through the word problems and be able to dissect them a lot quicker. So, good luck on your homework and good luck on your quizzes.